Okay, with trivia in the background, I'm going to point out here a spreadsheet, a Google document spreadsheet here, and I'm not going to necessarily, at this point, really expect that I should be making spreadsheets for you, but this one in particular, because of one of the limits of Google Documents, is that it can't iterate. An iterator would be constantly changing a value here, like you might see here, this number from 0 to 1 to 2 to 3, and pointing out that in fact the values here that you would be getting off when we fill the spreadsheet out would be the ones that would be pulled off when you did the data extraction. So remembering that we're pulling off for data extraction, each one of these lines would be effectively one of the forces. And in this case, we also want to remember when we're doing this evaluation, you solve for the reactions and then you describe the reactions as just forces in your description of your system. So in this case, you see at 0, 0, 0, there is a reaction of 10 in the x, 7.5 in the y, and 0 in the z. This, of course, I'm laying this out as a 2D. I'll do it the next time, remembering when you start to do this in 3D, z is up, x and y are x and y, northings and eastings reversed. So in this case, we're looking at this. I set this up as a 2D, and what you want to do is you're setting up your systems, even when you're drafting flat, realize that if you eventually go ahead and turn everything, rotate it 90 degrees, then everything will turn into 3D for something like, I don't know, maybe Revit or Inventor or whatever the case would be. So each line here describes a force radial vector pair. So this force is the reaction force, and I should have added actually over here. This is going to be reaction at A. And this is the reaction at B. And this is the applied force at mid-span. If you look at that, we've set our coordinate system to the left support in this point, and we have 15 down and a 10 tug to the left. So in this case, we have a force that's not directly across the beam, and I'm just showing you this so you can indicate and see how things work in terms of moments and the like. And if you remember, we're keeping these as 0, so we have no x and no y moment. We only have a moment about the z-axis as we usually describe it in a 2D problem. And in effect, because this is an equilibrium, you can see that these moments, and I'll click on one right here so you can see what they're calculated to be. It's just what we've been doing all semester and getting maybe too lazy about. It's this the add across left to right and subtract right to left in a 2x2 matrix. Remembering, of course, that is all k. And really, you want to fill these things out eventually with the x and the y so you can build some of these things to be a little bit more durable than just a 2D matrix. But you do a lot of 2D work. What I've got below here then, so this is basically your forces defined at some known datum 0, 0. This is going to be your subtractive, basically, as you're going and you want to evaluate in this coordinate system here. If you want to evaluate one to the right of that, you've got a coordinate x, y, and z, or your radial vector difference between where your original coordinate system was and where you want to evaluate. And you can see there is a spot there for y and z as well. Now there's all kinds of different ways to do this by shifting your coordinate system around in AutoCAD, but realistically you should just as easily be able to shift your coordinate system around in a spreadsheet or in a calculator. And so that's what we do down here below. Basically now, if in fact you have shifted your coordinate system one to the right, then the same forces still exist in terms of their magnitude and direction, but now their radial vector is different. And so if you notice here, that calculation is just the original radial vector in the x direction, which is 0, minus this coordinate shift. And so I've done that for each of those, which means each of these become the same. And now, in fact, then the moments change. The moments indeed, in fact, change, because if, in fact, all these things are applied, these moments should always continue to add up to 0 because you're just shifting across the structure. This is where, in fact, it then starts to get tricky, but not so tricky. if in fact you're trying to solve not for the reactions, which you already did up here in a side calculation perhaps. And remember, this can be more than 1, 2, 3, 4, 5. It can be an infinite number of forces. I think our calculators are set up to be 10. And I will give you the caveat right now that this is not set up to do the calculation automatically for distributed forces, which when in fact you cut your structure at percent perhaps, let's say something like position 3 to the right, you see everything calculate here, it's not going to recalculate your distributed loads. What does not change when you do that calculation is the reactions. The reactions are still there, but what you're doing is you're discarding everything to the right of 3 if you're working left across a structure. So in this case, you've calculated the moments of each of the forces, but only some of the forces, external forces, shear, and moment, are going to be calculated, and the opposite is going to be what is in your reaction. So in this case, you notice we have if statements placed. And this says, in fact, if you have shifted everything to the 0, the new 0, right, that if this is less than 0, then include it. If not, include it as 0. It is 0. In other words, if it is to the left of your new 0, 0 point, include it. If it's to the right, do not. And that's what each of these are. Include it if it is an axial force, include it if it is a shear force, and include it if it is a moment. And that moment, of course, is calculated with a new shifted vector because it is r cross f. You notice how these numbers do not change, but these numbers do. What you end up then getting as you go across the page, if you do it and change the number here, I'll go back and do 1, is you get a calculation, right, of what the moment is internally, what the shear axial force, the shear force, and the moment force is in the section cut, or the internal forces, the internal reactions in the beam. What this program does not do, which I believe Excel will do, but this does other stuff, is it would let you iterate that. So automatically go through and change this to be 2, and then change it to be 3, and then change it to be 4. In actuality, a calculator would make that even easier, perhaps, than working within this document. But this concept of kind of iterating through the structure, and eventually, potentially, changing the y and the z as well, if you're looking at working in 3 dimensions. Essentially going through this and discounting anything that is on the, I'm going to call it the back side of the section cut, as you're looking back to the structure and including those things that you do in wipeout and the like. So how do you go through and do this calculation across the beam if you want to do this method? And it's not the mathematical method, it is the iteration method, and it is a great method for you to learn to really start to tie together AutoCAD and Excel. So here, how do you do that? Well, all you do is you do the number here. We'll start with 1. That calculates this here. You just do a copy and paste values in this case. In this case, you go here, right click, copy, here, right click, paste, and you want to paste values. So when you do your paste, edit, paste values only. And now if we change this to 2, in other words, we're 2 units to the right of our original origin, for which the original lines were defined, you just go ahead and grab this. And I would say you're better off doing a copy and then edit, paste values only. And I'll do 1, 3, and I'll do 4. And you'll see where it gets odd is on those odd numbers where you actually have an absolute force. So it's nice to do exactly 4.9 and 5.1, but I'll just go ahead and do 3. You see the numbers change. Paste values only, and then I'll do finally number 4. Now you can learn to set things up. Sorry, number 4 here. You can learn to set things up. You see it's calculating again. You can learn to set things up so this does this automatically, and it is worth investigating how to plug it in your calculator and the like. Edit, pace values only. And definitely within Excel, it's an iteration, it's a what-if analysis, I think it's called. It's in Access, it's in Excel. But right now what you have is in fact the internal, not only the shear and the moment diagram, but you will also can get the internal axial forces as you think about basically any push or pull along the long axis has to only exist in between the applied force and the pin joint in something like this. Now it does differ when you get into fixed end moments, but this is the calculation.